Now in this mini lecture, we're still working with the same data on iPad ownership and gender, but if you'll notice, I also have other data regarding how much money somebody makes and their height. So in this particular mini lecture, I'm going to assess whether iPad ownership or gender, or both for that matter, but whether iPad ownership or gender might help predict somebody's income. And if you'll recall, even though we say that in regression analysis we should work with quantitative data, I showed you how to do what we call dummy variable regression. And since the variable for iPad ownership is a two-level nominal, and the same way with gender, a two-level nominal, we actually can do dummy variable regression to predict somebody's income. Okay? So income becomes our dependent variable, and our two independent variables are iPad ownership and gender. And I'm going to run this as a multiple regression problem. I could do simple regressions, but I'm just going to do it all at one time. Okay. So I'm already at the add-ins tab. So I go over to Megastat. I click on Megastat. I drag down to correlation regression. And I drag over and down to regression analysis. Okay. Let me clear everything out here. And so now it asks for my independent variables. So I'm going to click on my column headers for my independent variables. And then I'm going to drag down all of my rows to highlight the data for my independent variables. Okay? And I'm going to do the same thing for my dependent variable. And remember, my dependent variable in this instance is income. So I highlight the column header for income, and I drag down all the rows of my data for income. Okay? I'm going to ask for variance inflation factor and standardized coefficients. Not that they're really all that relevant with dummy variables, but I'm going to click on OK. And what do I get? Well, I get a kind of an unexciting R squared of it explains 20% of the variance. That's not bad, but certainly it's not up in the 0.7, 0.8, 0.9 range like we would like to have it. And I get a small p-value in my ANOVA table. So my regression model does help predict my dependent variable. Okay? Does an okay job, doesn't do a great job. And what we see here is that iPad ownership is statistically significant from zero, the p-value for iPad ownership, but the gender does not help predict income. Okay? So if I wanted to be technically correct, I would rerun this as a simple regression model, dropping out gender and only using iPad ownership. Oh, I should also mention, I was actually looking at this but didn't make mention, my variance inflation factor is low, so I'm not really concerned about a problem here with multilinearity. Okay? Alrighty. And what this 23, so let me just build our regression model once. We would say income equals, let's say 39.18 plus 23.37 times iPad. Okay? Let me make this a little bit bigger so that we can see it. And again, technically I should have rerun the model, but just for really purposes of saving time here. What you see is that we're going to, so if somebody doesn't own an iPad, based on our data, if somebody does not own an iPad, we predict they would make $39,180 a year. If somebody does own an iPad, we predict that it would increase their income by $23,370. Now, iPad ownership can only take on two values, 1 or 0. If you don't own an iPad and you have a 0, then 23.37 times 0 is 0, so we predict the income would be $39,000. But if somebody does own an iPad, they're assigned the number 1, so 23.37 times 1 is 23.37 plus 39.18, whatever number that comes out, that becomes the predicted income. And what do we have for the 95% confidence interval, fairly broad, fairly broad. A low of about $14,000 to a high of about nearly $33,000. Okay. Nevertheless, we can use iPad ownership and gender to investigate whether they help predict somebody's income. And in this instance here, owning an iPad helps predict somebody's income, but a person's gender does not help predict their income. Thank you.